Alright, so next up we have problem number 9. Problem number 9, we have a 100 watt light bulb. Now again, this is power. Okay, this is a rate. This is the power required to run it for 1 hour. So now it's asking how many watt hours of energy are used in 12 hours of operation. Now again, no dimensional analysis is really needed here because energy, so if I'm coming back here, energy is equal to power times time. So if you have power at 100, how many hours did it run for? 12. Then you can get an energy, and it doesn't have to be the kilowatt hour. It could be any any of these. So like if you did BTUs times this, then you can get a unit for energy. So coming back over here, so how many watt hours of energy are used in 12 hours of operation? Well, that's 100 times 12. That's 1200 hours, or sorry, 1200 watt hours of energy that are used. So again, just showing you this on the paper. So you have 100 watts, and again, you want your hour. So this is problem A. So you want your answer to be in watt hours. I'm going to box it right now, and this is run for 12 hours. So that's 100. So that's 1200 watt hours. Done. Takes care of problem A. Alright, problem B. So coming back over here. So now how many kilojoules were used in 12 hours of operation? Okay, well let's kind of take a look. So we know we have a watt hour. Okay, so we know we have a watt hour. Can we go from watt hours to kilojoules? So let's take a look here. So you have kilojoules to joules. You have joules here, so you can go watt hours to joules, and then from joules to the kilowatt hour. So that's one way to do it. Okay, so again, we're going to set it up using dimensional analysis. So coming back over here, we know we have 1200 watt hours. We don't want it in watt hours, so we're going to have to cancel out watt hours. So let's come back over here. So how are we going to do that? Well, you have the watt hour here. And what is the answer? See, because I should have done this at the very beginning. I'm looking for the total in kilojoules. So in kilojoules. So we come back over here, and I'm going to box my answer now. It's in kilojoules like that. All right, so is there any conversion between watt hours and kilojoules? I didn't see any. Not from kilojoules to watt hours, but I do see joules right here. Okay, so I'm going to go back and go 1 watt hours equal to 3,600 joules. Now I know there's a conversion between joules and kilojoules, so that's right here. So it's 1,000 joules to 1 kilojoule. So let's come back over here. So it's 1,000 joules to 1 kilojoule. Cancel, 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 left with the kilojoule. So now it's really just 1,200 times 3,600 divided by 1,000. So again, I can do the scientific notation. So 1.2 times 10 to the third times 3.6 times 10 to the third divided by 1 times 10 to the third. Okay, so this is addition, subtraction. So again, I'm going to do this in 3 parts. So 3.6 times 1.2, so it's 12. 6, 7. That's 6, 3. Here. And then 2 decimals, 1, 2. So this is equal to 4.32. divided by 1, because again I'm doing the first part, so divided by 1 is still 4.32 times 10 to the, so this is 3 plus 3, that's 10 to the 6th, minus 3, back down to times 10 to the 3rd. Okay, and that is how many kilojoules I have right there. If I wanted to write this out, again I'm moving to 3 decimals, 1, 2, 3, that's 4,320 kilojoules as my answer, like that. All right, that takes care of part B. All right, let's go over to part C. So now it's how many BTUs were used in 12 hours of operation. And it says right here you can start with watt hours or kilojoules because they are both quantities like BTU. So let's go back to our problem. So I can go from here to BTUs or I can go from here to BTUs. So let's go to our conversion chart. And the first one I see is, so I can go kilojoules to BTU. So I just got to find a conversion for that. So I don't really see a kilojoule. So there's a kilojoule to joule. What about a watt hour to BTU? So, so I got a watt second. So I could do that. So, but there's no, so like if you look, there's no direct conversion. All right. So let's try the kilojoule again. So I can go kilojoule to joules, and then I can go joules to watt seconds, and then watt seconds to BTU. It's kind of a lot. I can go, oh, how about this? Look, I can go watt hours to kilowatt hours, and then I can go kilowatt hours to BTU. I kind of like that. I'm going to go with that. So let's go back down to the problem. So I'm going to go with the watt hour to BTU. So let's do that. So this is 1,200 watt hours. I'm going to cancel out the watt hour with the kilowatt hour. And then I know there was a kilowatt hour to BTU. Okay, so let's go back to our conversion chart. So again, right here, I was looking at this, watt hour to kilowatt hour. So that's 1,000 to 1. That's 1,000 watt hours to 1 kilowatt hour. And then let's go to kilowatt hour to BTU. So 1 kilowatt hour to 3,000. 1 kilowatt hour to 3,412 BTUs. And again, this is just now a scientific notation problem if you want. Another way to do this is like, 1,200 divided by 1,000. Like you could do that first. So you can just make sure this stuff cancels. So it's really like 3,412 times 1.2. Again, you could do the scientific notation. There's a bunch of ways to do this. So 4,286, 2, 1, 4, 3. All right, so then you would end up with this. So 4,944 BTU. Like that. That's, oh, sorry. Gotta put the little dot there because I forgot it's a 1 decimal. So you would end up right there for BTUs. And that's pretty much it for problem number 9. Oh, actually there's a part D. So again, this was C. So again, if I'm going over, again, make sure you label, especially on the AP test. So coming over here, and go to part D right here. Part D, if the light bulb is only 20% efficient, how many joules will be converted over into light over the 12 hours? Well, we already know how much energy it's using for 12 hours. We have it in BTUs, we have it in watt hours. This is going to ask it in joules though, so in joules. So let's go back over here. So we have the energy, take a look, in watt hours, we got it in kilojoules, and we got it in BTUs. It's already in kilojoules, so we can just switch that over to joules and then 20% efficiency. So this is 4,320 kilojoules times 20% efficiency. Okay, and that's going to give us this in kilojoules. And then you need to take this in kilojoules. Okay, and then remember kilojoule, so 1 kilojoule, 1,000 joules. And that will give us our answer here. So I'll let you guys work out the math on part D. Finally, on part E, it's asking, because I want to keep the problem under 10 minutes, it's asking if it's only using 20% of the energy, where is the rest of it going, and what law does this apply to? So again, you have your bulb right here, terrible bulb, and it's giving off light, okay, and this is 20% of the energy. The other 80%, remember those incandescent bulbs are really hot, 80% of it is being lost as heat. Together, it equals 100%. So this actually applies to the second law of thermodynamics. So if you remember, the second law of thermodynamics means that as energy is used, so again, energy in the form of joules, okay, it's going to be used into less usable forms. So heat is one of them, and over here you have light as another one. So again, it's just being so the energy, so you can also apply it to the first law of thermodynamics, like the total energy isn't destroyed, it's maintained, it's just changed forms into something else.